All right, so today we're going to talk about relationships between arcs that are bisected by chords or lines that aren't anything that we've talked about already, and the angle relationships formed. We've spent a lot of time talking about central angles and the arcs they intercept, and we've talked about inscribed angles and the arcs they intercept. But what if an angle isn't inscribed or a central? How does that relate to the drawing? And we've basically got two cases here. We've got cases where we're going to take half of the sum of the two arcs, and we've got cases where we're going to take half of the difference of the two arcs. And anytime we're taking the difference of two arcs, it'll always be the bigger arc minus the smaller arc. So let me just kind of look at those two cases and go into a little bit of detail. If I were to draw a circle, and then I didn't even complete that circle, did I? And then after drawing the circle, if I were to take some lines and cross them. Okay, notice that we formed four angles by crossing those two lines. Angle 1, angle 2, angle 3, and angle 4. Any of the measures of those angles can be found by looking at the intercepted arc and the intercepted arc of its vertical angle. So for example, if I wanted to find the measure of angle 2, I would look at the arc that angle 2 intercepts, and I would also examine the arc that its vertical angle, angle 4, intercepts. And to find the value, I'm just going to add the yellow and the purple together and divide by 2. So that's basically what this says right here. That the measure of the angle where the angle's vertex is somewhere in the interior of the circle will be the sum of the arcs made by the angle it intercepts versus the vertical angle that it intercepts. Just add those two together, divide by 2. Now, that's what happens when we cross and have the vertex in the center. What happens when the vertex isn't in the center? So I'll just get rid of this stuff right here, and we'll make another line. And now the vertex of those two lines are going to be outside the circle. So I can either be the center of the circle, I can cross somewhere in the interior of the circle, I can cross on the circle, or I can cross outside the circle. If you notice though, if I'm looking at angle 1 right here, there are two arcs, that arc and that arc, that get intercepted by angle 1. So if I look on the inside of angle 1, it cuts the circle in two places. This is where you get that subtraction. And the subtraction property can come from where both of the lines make chords, or if I want to, instead of one of the lines being a chord, let's make it a tangent line. So now, if I've got this tangent line here, what do you notice about the arcs? Well, this green one goes all the way to here, and then this yellow one goes all the way to here. So at the point of tangency, those two arcs become adjacent arcs. And then if I actually do two tangent lines, something interesting happens with two tangent lines. The arcs actually become, adjacent arcs that form the entire circle. So the green arc is one part of the circle, and the yellow arc is the rest of the circle. If you add the green and the yellow together, what do you have to get? 360. In each case, whether or not the lines go through the circle whether or not one of the lines is tangent or whether or not both of the lines is tangent. The angles measured can be found by subtracting the two arcs from each other, the bigger arc minus the smaller arc, and then dividing that by 2. So we basically have ways of now finding any angles that exist as the lines go through the circle. No matter where our vertex of that angle is, we can find that angle's measure. If it's a central angle, its measure is based on the arc it intercepts. They're equal. If it's an inscribed angle, its measure is based off of 1/2 of the arc it intercepts. If the angle is in the interior, it's going to intercept 2 different arcs, and we add those arcs together and take 1/2. And if the angle is outside the circle, then it's the difference of the 2 arcs it cuts off, no matter whether it cuts off 2 complete arcs by making chord-like drawings inside the circle or where one or both of the lines are tangent. We have a subtraction problem of the 2 arcs that are cut off and a multiplication of 1/2. All right, so what does this mean? Well, we can now find angle measures given virtually any circle picture based on knowing the arcs of the circle. So this is all about using arc measures and finding angle measures. And why is that important? Because if you can find angle measures, then you can start turning stuff into triangles. And if you start turning stuff into triangles, then we've got the Pythagorean theorem and we've got all that trig stuff that we've learned. And triangles are the most basic polygonal shape, so they're important. Relating triangles to circles is an important thing. All right, so in part 1 here, the angle crossed is inside. So what do you think we're going to do with those 2 arcs?
1/2.
Right. So x is going to equal 1/2 something. What are we doing with those 2 arcs?
Adding.
Yep, so arc 1 plus arc 2. And it doesn't matter what order you add in. So in this thing, it's going to be 1/2 46 plus 90. So 46 plus 90 is 136. And when I divide that by 2, I get 68. So x is equal to 68 degrees. Does anybody have any questions about how I set it up or why I added? The important thing to remember is if it crosses in between, inside the circle, and it's not an inscribed angle, and it's not a central angle, then you add and divide by 2. By the way, if it's an inscribed angle, there'll only be 1 arc, and we're dividing that arc by 2, so that kind of makes sense. If it's a central angle, the 2 arcs will be exactly the same measure, and if you add 2 numbers together and divide by 2, you get what you started with. So it kind of even works for central angles and inscribed angles. All right. Now this is a little bit different. Where's the angle? Is it inside the circle? No. And so now the variable is also one of the arcs. So this is going to be 20 degrees, the measure of the angle, equal to 1/2 the bigger arc. Which do you think would be the bigger arc in this case, 95 or Z? Yeah, 95 is going to be bigger because it's further away from the angle. And it's a subtraction problem when it's the angle vertex is outside the circle. So a little bit different. We've got a situation here where we're having to solve for Z. It's not just an expression we're solving. Now we're solving an algebraic expression, or algebraic equation. I would probably multiply both sides by 2 to get rid of the fraction. And then I would subtract 95. So 40 minus 95 is obviously going to give us a negative answer, negative 55. Oops. And so negative 55 is equal to negative Z. So multiply both sides through by -1, divide both sides through by -1, whatever your passion is. You can do it either way. And you get Z is equal to 55. Yes, sir?
So you subtract 40, no, you wait. How did you get 40?
Okay, so I started out with the equation 20 is equal to 1/2 times 95 minus Z. This is the angle. This is the 1/2. This is the bigger arc. This is the smaller arc. So how did I get the 40? Well, I don't want to deal with this 1/2 here, so if I multiply this side of the equation by 2, 2 times 1/2 goes away. Whatever you do to one side, you have to do to the other side. So if I multiply this side by 2, I got to multiply this side by 2. 2 times 20 is 40. So effectively what I've done is I've said, hey, let's multiply this side by 2, not 1/2. Let's multiply this side by 2, and let's multiply this side by 2. 2 times 1/2 cancels. 2 times 20 is 40. Does that make sense?
Yes, sir.
Any other questions? All right. Let's see if you can find the values of the variables in each of these figures. And after you find them for A, B, and C, I want you to check with your partner. All right, so hopefully we've had a chance to compare with our partners. For number 1, what are we doing here? Are we subtracting arcs or are we adding arcs? Which arc do you think is bigger? W, because it's the furthest away from the angle. And so anytime we do these, of course, we're going to do something to the arcs and take half of it, and it's going to equal, oops, I've already made a mistake. It's going to equal half the angle. So Jackson, what do you think I should do first here?
You would multiply by 2.
Yeah. So that's going to give us 140 is equal to W minus 110. And then what do you do with the 110? Add it both sides. So 250 degrees is going to equal the measure of arc W. Everybody get that one okay? All right. Subtraction or addition problem here. Subtraction. Y is equal to the furthest angle is 110. The closest angle is 30. So that's 1/2 of 80, which is equal to 40. Everybody okay with that? And then finally, we got a subtraction problem or an addition problem here? Addition. So the angle is 35. Does it matter what order we add in? Nope. So we can do x plus 30. What should I do first here to make this a little bit easier?
Remove the fraction.
And how do you do that? Multiply by 2. So that's going to be 70 is equal to x plus 30. And then subtract 30 from both sides. And x is equal to 40. So some real simple arithmetic problems to get you kind of used to the concept of what's going on here. Now let's take a look at what these might look like as a word problem. I'll make this a little bit bigger here. Oops. All right. So we got planet Earth, and there's a satellite orbiting the Earth, and it has a viewing angle formed by the two tangents. And we know that the viewing angle is about 7.5 degrees. What is the measure of the arc of the Earth that is viewed from the satellite? So basically what I want to know is I want to know what this arc measure is right here. Here's the satellite. How do I find that? So I'm dealing with basically two arcs. I'm dealing with, and the one I'm trying to find is the measure of arc AB. But notice there's a point E up there, so I can refer to the major arc, arc AEB. So I'm really dealing with two arcs here. I'm dealing with this arc right here, the green arc, which I'm trying to find, and then this arc right here, the yellow arc. Well, what do we know about the relationship between the yellow arc and the green arc?
It all equals 360.
Right. So yellow plus green is equal to 360. A lot of times I ask you to write things in terms of other things. What variable did I choose for green? X. And you could choose any variable you want, but how would I solve for yellow in this equation here? What would I do to get yellow by itself? Subtract x. So couldn't I say that the yellow arc is equal to 360 minus x? If I'm going to say the green arc is equal to x, then the yellow is 360 minus x. And will that give us enough information to make an equation if we know this angle? Well, it's angle is equal to, what's the formula? 1/2 big arc minus small arc, right? And in this case, what's the big arc? 360 minus x. What's the small arc? And what's the angle? 17.5. So if I take, I know that's annoying, that stuff popping up. If I take this very, very simple equation right here, and I'm not sure that that's written neat enough for me. Let me rewrite that a little bit neater. Let me erase that and write it a little bit neater. All right, so the angle was 17.5 times 1/2. The big arc we said was 360 minus x, and then the small arc was minus x. So if I take that information right there, if I take that equation and I just do algebra on this equation and just solve this equation, what's the first thing I'm going to be able to do? What should I do first inside the, remember, parentheses are groups, so you really should work with those as much as you can first. So can I change minus x to something simpler? What? Minus 2x. And then how should I get rid of the 1/2? Multiply both sides by 2. So if I multiply the right side by 2, I get 360 minus 2x. If I multiply 17.5 by 2, I get 35. Now if I subtract 360 from both sides, I get 2x is equal to negative 325. And then if I divide both sides by negative 2, so I get 162.5.
Why would you not add 360 to 35?
Well, if I add 360 to this side, it goes to 720. And I haven't gotten rid of it. So remember, I'm trying to eliminate. I've got to do whatever it takes to get rid of 360 on this side. Since 360 is a positive number, the only way to get rid of it is to subtract. Does that make sense? Okay. So back over here, x is equal to 162.5. So that just tells me the degree measure of the arc. But if I knew something weird like the radius of the Earth was 4,000 miles, could I find how much of the land I could see? Yeah, I could almost have some sort of linear path from how much of the land my satellite could observe. That might be really important if I were trying to program the satellite to cover certain stuff. Might be really important to know how much land it covers. The further out you get your satellite, the smaller this angle is going to be, the smaller the amount of stuff you're going to be able to see here. The closer in, the better, the more stuff you'll be able to see. So knowing where to put your satellite in orbit might be important. And you might not have a whole lot of choice because orbiting has to be within a certain range. It has to be at a certain height to be able to orbit. Otherwise, it'll float off into space or crash back into the Earth. Got to get that gravity sweet spot. Pretty interesting stuff. All right. All done with circles and angles. All right. So let's take a look at how to find some segment lengths. When you start drawing these lines, there starts to be a relationship between the lines at the point of intersection. And based on how far they are from wherever they are, wherever the intersection is, to the circle. So in case 1, the products of the chord segments are equal. So if I cross 2 lines inside the circle, the products of each segment of the chord are going to be equal to each other. In other words, the blue chord got divided, so if I take its 2 halves and multiply it together, and the red chord got divided, if I take its 2 halves and multiply them together, the two products are going to be equal to each other. We could do a proof about why that is, but I'm not going to. All right. If the line is outside the circle, then the products of the secants and their outer segments are equal. All right. So what's a secant? A secant is a line that, so a tangent line is a line that only touches the circle in 1 point, and a secant line is a line that touches the circle in 2 points. So if I'm talking about a secant, I'm talking about the chord formed by the line, and if I'm talking about the outer segment, I'm talking about just the line segment that's outside the circle. Now, if you're talking about a tangent line, then you're just going to tangent it squared. But here we've got a secant part and an outer part. Here we've got a secant part and an outer part. A secant part and an outer part. And so here are the equations that you use for each of these. So basically, if I take the distance of the outer part and add it to the distance of the inner part, which would technically be the length of that whole line, and then multiply it by the outer part, that's going to be the same as the distance from the other line, its whole line length, times its outer part. If you think about it, what I'm multiplying is I'm multiplying the distance from the point to where it crosses the circle in the first time, and the point and where it crosses the circle the second time. Same thing here, from the point to the first crossing of the circle, from the point to the second crossing of the circle. From the point to the first crossing of the circle, oh, it's the same point when I do it a second time. And here from the point to the first to the point to the second. So we're probably going to have to be really careful about using the segment addition property as we start doing some of these problems. These are probably the hardest problems we've got in this chapter. In chapter 5, or in unit 12, this section right here, this particular stuff is the hardest. Because it's just a lot of stuff to remember. Keep in your brain, I'm looking at distances from point to pieces of circle. And that keeps it straight in your mind whether you got to add stuff or not add stuff. Jay, you with me? All right. So here we go. Let me give you a sample. So here in part A, if I want to look at the products, the point is outside the circle. So if I do two distances and compare the products, if I look at the top line, so let me highlight the top line here. The top line will be this yellow line right here, and then the bottom line will be the green. So if I look at just the top line, its distance from the point to the circle is 6, but its other distance from the point to the other side of the circle is 6 plus 8, right? That's a pretty horrible handwriting there. I'm going to make that a little bit better. Trying to improve my onboard penmanship here. And that's going to be equal to the product of the green line from its point to where it crosses the circle. Now, where it goes from the point to the circle the first time, that's just 7, right? But how far is it from the whole length of the green line? Yep, 7 plus y. I'm going to do y plus 7 because I always like to put my variables first. I'm just crazy that way. So if I simplify this up, this is 6 plus 8 is 14. And 14 times 6 is 84. So here's our algebra problem. This is just straight out of Algebra 1 right here. How would we solve this problem? Well, first you would distribute. So that's going to be 7y plus 49. And then you would take 49 from 84 and get 35. And then you would divide both sides by 7, and you would get y is equal to 5. So finding y right there, no problem. This one's a little bit more complicated. Because if you look at, once again, I'm going to divide it up into a green line and a yellow line. If you look at the green line, it's tangent. So its closest and farthest part is the same number. So what's z times z? Z squared. So z squared will equal, and then what's the closest distance for the yellow line to the circle?
Is that 8?
8. That's an 8. And then what's the furthest distance? A lot of people will make that mistake, but it's 16 plus 8, or 24. So z squared is equal to 8 times 24. So z squared is equal to 8 times 24 is 192. So z is equal to the square root of 192. And so what I'm going to have to do is I'm going to have to take the square root of 192 and simplify it, because it doesn't say to round off. So if it doesn't say to round off, we should leave it in simplest form. So the square root of 192 simplifies down into 8 square root 3. I use my calculator, but you could prime factor 92 out and find that it was 2 times 2 times 2 times 2 times 2 times 2 times 3. And then there are 3 pairs of 2's, which multiply back together to give you 64. And the square root of 64 is 8. Everybody okay with that? Alrighty. Here you go. Here's 2 problems. I want you to do A and then stop. And we'll talk about A. And then we'll do B. And I'll give you a hint. In B, you're not adding anything. But in A, you got to add some stuff to get lengths of lines. All right, let's take a look at A. So for A, I've noticed that my line has its vertex, or my angle has its vertex outside the circle. So really, my distance between the point and the first one, the outer segment, is going to be just 14, but the other one I'm going to have to add the 2. So that's going to look like 14 times 14 plus 20. That's one product, and that product should equal to the outer length 16 times the whole length, which is x plus 16. So is everybody okay with that setup? Are we comfortable there? All right, so moving right along, I'm just going to go ahead and do the product. 14 plus 20 times 14 would be 14 times 34. And I get 476. And then that's going to be 16x plus 256, 16 squared. And then I can just subtract 256 from both sides and get 220 equals 16x. It says find my answer to the nearest tenth. So I'm okay with having a decimal answer here. It came out to be 13.75, but since it told me to the nearest tenth, I guess I'll go ahead and round off to the nearest tenth, which would be 13.8. Any questions about that one? All right, let's go ahead and work B. I think B actually is a little bit easier than A, but go ahead and work it out real quick. All right, let's take a look and see what you get for this one. So in this one, it crosses on the inside. The distances are just going to be the 2 different segments of the line. So that's 3 times 7 for one product, and m times 6.5 for the other product, which is 21 is equal to 6.5 m. I'll divide both sides by 6.5. So 21 divided by 6.5 gives me 3.23 something. I'm just going to put 3.2 because it said to round to the nearest tenth. Is everybody okay with that?
Yes.
Okay, does anybody have any questions? All right, so that's it. You can